All right, guys. So, does everybody have these notes out?
Yep.
Okay, good. So, what I'm going to do is I'm going to kind of talk us through the notes. All right. We are going to. You didn't tell me that I didn't put it on the screen for you guys. That would be helpful, right? Where did I put my remote? Now this is going to be on the recording. Hi, 2B. Everybody say hi, 2B.
Hello.
Say hi to Brahito. Brahito's in this class. All right, let's get back to work here. So everybody has these notes out. So if you have different answers in your key, please make sure you're making the changes accordingly, okay? All right, so it says the study of how the universe began, how it continues to change, and what it's made of is called cosmology. Sounds like cosmetology, but it's not quite. All right, in 1929, Edwin Hubble discovered that almost all matter, or all galaxies, excuse me, are moving away from Earth. Okay, this can only be explained if the universe is actually expanding, right? If things are moving away from us, that means they're expanding, or everything around us is expanding away from us, okay? So the Big Bang Theory is this idea that all matter and energy were compressed into a really, really small point. It was so small, it was smaller than atoms, okay? Yeah, into a small singular point. Okay? And then the Big Bang itself is when that point suddenly started expanding. Right? But I just want to be clear that it wasn't an explosion. It was an expansion of space itself, all right? It was an expansion, not an explosion. So there wasn't like hellfire and missiles and a bunch of things. It just got bigger, yeah, but like really, really quickly. So it looks like an explosion, but it's not an actual explosion. It's just a really, really rapid expansion, okay? So cosmic background radiation. This right here is the radiation that's left behind from the beginning of the universe, okay? That's okay. What did you put down, Jesse?
I put residual microwave radiation when the universe was young.
That's the same idea. So radiation that was left behind from beginning. So residual means left behind, okay? And residual microwave radiation is just specifying the type of radiation. Tony? They're over there. They're extras over there. All right. Okay, guys. So residual microwave radiation that was left behind from when the universe was really young. And I have a video for you guys to watch later today that kind of explains that a little further. All right, the Doppler effect, and we're going to talk about that extensively today. Okay, the Doppler effect just shows the speed and direction of galaxy movement, okay? Speed and direction of galaxy movement. Okay, so kind of summarizing this, the Doppler effect, so this is summarizing this up here. As a light source gets closer to you, the wavelengths get shorter. As a light source gets further away from you, the wavelengths get longer. So I actually want to show this as a little demo here. So we're going to do this. Okay, so watch me on the TV. It's kind of weird. Hi, everybody. Okay, hear me out though. Watch. So this right here, this is going to be our wave, right? You can see it's got crests, it's got troughs, right? So how the Doppler effect works, and you guys have heard this before, right? When you're like standing on the curb and then all of a sudden an ambulance passes by you, right? And it goes like, wee woo, wee woo, wee woo, wee woo. You know what I'm talking about? Yeah, we've all experienced the Doppler effect, right? We've all experienced this. This is so bizarre. Okay. So hear me out. When we have sound waves being produced, listen up. When we have sound waves being produced, so for instance, the siren, let's say the siren's over here, it's going to be shooting sound waves into my ear, right? We're going to hear these sound waves. It's coming into my ear. Watch what happens when the sound waves get closer. No, it's not going to shoot me. Listen. Watch what happens when the sound waves get closer. What's happening to the waves? They're condensing, okay? They're getting shorter, right? They're getting shorter, which means if the wavelength's getting shorter, what's happening to the frequency? It's increasing, right? So if the wavelength goes down, the frequency goes up. So watch when the wavelength starts going away from me. What happens to the sound waves? Yes, the sound waves are getting longer, okay? So the Doppler effect tells us as things move closer to us, the waves condense, and when they move away from us, the waves stretch, just like the slinky. Does that make sense, you guys?
Yeah.
Good. So back to our notes. That's okay. Guys, folks, I need you to pay attention. Okay. So, maintaining focus here. Speed and direction. All right. So by measuring the Doppler effect, we have determined that the universe is expanding, okay? This is mainly due to the galaxies exhibiting something called red shift, okay? Red shift is due to the Doppler effect as well as the stretching of space and as the universe expands. Now that seems like really, really intense or really weird, but I'll explain it to you in just a moment. So due to the Doppler effect, as well as the stretching of space as the universe expands. All right, it's called redshift, okay? That's kind of an interesting idea. The other day we were looking at this, right? Do you guys remember looking at this? The electromagnetic spectrum. All right, so the reason why it's called redshift is because what happens when something's moving away from me, guys? Right? The wavelength increases when something's moving away. Look at this. I mean, I know this is black and white. Bear with me. As we move away, the wavelengths are increasing. So that means we're on this side of the spectrum, right? These are longer wavelengths. This is actually red in color. Okay? So if we're moving away, the wavelengths are stretching and producing a red color. All right? If the galaxies were moving towards us, what's happening to the wavelengths? They're decreasing, right? Because they're getting smaller, they're condensing. So they're getting smaller. And this over here is actually blue in color. So if things are moving close to us, the waves are condensing and becoming blue. That is called blue shift, okay? Well, the middle is actually like, it goes like red, orange, yellow, green, blue, purple. That's how it goes. All right. So we are going to stop the recording right now. Bye, everybody. It's not stopping.